Hello everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So, in this particular class, we are going to do the module three-phase system, and in that three-phase system, in today's agenda is to study the three-phase power measurement. So, in the previous classes, we have studied what is three-phase system and its importance is what are different types of connection we have, phase voltages, phase current, uh, line voltage, line current, their relationship. So those things, star delta circuit connection. So those things we have discussed. So here we will going to see what are the different types techniques we have, different method we have for the measurement of three-phase power in a balanced and unbalanced circuit. Okay, so let us start. So before going to those mathematical calculations, first we are just recapping that the previous concept already that we have discussed, that is the what is three-phase system. So basically a three-phase system is a nowadays is widely used electrical system by which the generation, transmission, distribution is everything is done. Okay, so let us check what is written. So it is written over here. It is that three-phase power is a common method of alternating current electric power generation, transmission, and distribution. That means whatever I am telling, that in any generating station, alternating power is generated, and that power is generated in three phase. So whatever power is generated, so that thing is transmitted. That should the system or network should be three phase. And when it is transmitted to some area or some substation, after that there is a distribution of power. So when there is a requirement of high voltage, high current, that means high power we needed, then but we use actually the three-phase system. Okay, so number 2 point, it is a type of polyphase system and it is the most common method used by electric grids worldwide to transfer power. So it is a very important, very interesting point. So the point, why that point is interesting, that say in India. So in India there are different states and some private companies are generating. They have their own generating stations, and in those generating stations a huge amount power is generated, maybe thermal, maybe hydro, maybe nuclear, whatever is the source of energy. So the main point is the different powers are generated in different zones, correct? So all should have same pattern, so that all power whatever say in West Bengal some powers are generated, and we have to transmit that power to the Karnataka. So there is a West Bengal, there is a Karnataka. We have to transmit power. So if say the frequency range, if the it is polyphase, it is single phase. If those are different, then we cannot for any requirement, for any emergency, we cannot transmit power from West Bengal to Karnataka or Karnataka to West Bengal. So that's why the common the system, electrical system is implemented all over the world, so that the power can be transmitted from one zone to another zone or from anywhere to anywhere. So this, what is now the term that electrical grid. So what is electrical grid actually? So grid is a system where all the generating stations, that means power transmission lines are connected. So grid system is like a power pool where all different generating station transmission lines are connected, and from where we can, if there is any electrical emergency of some states or some area, so from there we can the electricity department can buy energy and can give us that energy. So that kind of thing is the grid system, and in India that is the national grid, and that is the main electrical company in India which is actually dealing with this huge power transmitting and distribution system. Okay. Next point is a polyphase system is a means of distributing alternating current electrical power. Yes, I have already told this one that electrical powers are generated in its alternating form. So we have to transmit that power in that form only. So that's why there is the importance of three-phase system. And let us say the last point: an electrical grid is an interconnected network for delivering electricity from suppliers to consumer. As I am telling you, so that is a electrical pool type thing. That means all systems are interconnected to each other. Someone say this system is generating the power, but a huge amount of power is generated by this. Say there is a substation, so generating station, and this generating station is generating a huge amount of energy, but that amount of energy is not required for that particular area where it is actually supplying power. So the waste extra amount of energy can be sold to the other consumer where there is a demand. So like this way, demand and supply, there is a chain, so that there is and we are the citizen of India is consuming those powers, so that there is 24/7 uninterrupted power supply should be there, because we are paying for the electricity. So we need 24/7 in the city. So for those systems, for the modification of the system, so there are these three types of systems are nowadays implemented. Okay, coming to the next slide. Okay, so now we are going to see what are the methods we have for the measurement of power. Yes, various methods are used measurement of this three-phase power in three-phase circuits on the basis of number of wattmeter used. So we have basically three methods. So what are the methods? 3 wattmeter method, 2 wattmeter method, and single wattmeter method. Okay, so as the name suggested, that means when we are using the 3 wattmeter method, that means there we are going to use 3 wattmeter. So 2 wattmeter method is a method by which we are going to measure three-phase power by 2 wattmeter. There is a method where we have a single wattmeter, and by that we are going to measure the three-phase power of a three-phase line, a three-phase system. Okay, so each method has its own advantage or disadvantage. So now one by one I am going to discuss with you what are the methods we have and how the power is measured. Okay, so some method has some advantages, some method has some disadvantages. So let us see one by one what are those. Okay, so measurement of three-phase power by 3 wattmeter method. Now we are going to do a method where we are going to use 3 wattmeters for three-phase power measurement. Let us see. Yes, 3 wattmeter method is used to measure power in a 3-phase 4-wire system. Very important line. 3-phase 4-wire system. So that means 3-phase 4-wire means that is a star connection where 3 phases are there but wire are 4. Why there is a wire 4? Because in star connection what we have? 3 phase and there is a neutral line. So how many wire is there? 3 phase and the neutral line. The 4 wire is there. So number 2 point. So however this method can be used in a 3-phase 3-wire delta connected load. Remember this point. It can be used on the delta connection where 3-phase 3-line wire is needed, where power consumed by each load is required to be determined separately. Okay, 3-phase wattmeter method can be used for star and delta connected unbalanced load. Yes, very important point. If we just go for the next slide, there we can see the diagrams and we can very easily understand why I'm telling you the unbalanced load. Because if we have a if each phase is consuming the same amount of power for the same amount of time, then there is no need of using 3 wattmeter. So we can use a single wattmeter. So we are just measuring any phase power and multiply by 3, we will get the 3-phase power. But not that like that. But if the system is unbalanced, so each phase has the magnitude as different, voltage level is different, phase angle between them is different. So that is unbalanced system. Okay, so balanced system means each has same a magnitude and they have 120-degree phase shifting. But it doesn't happen, then it's the unbalanced system, and for that case each phase is consuming different power. So how much power is consumed by each phase, that can be found out by this three-phase 3 wattmeter method. Okay, coming to the next slide. Yes, this is the connection for the star delta connected loads for measuring power by 3 wattmeter method is shown below. So here, as we can see, the above diagram is representing a star circuit and the below diagram is representing a star circuit. Now, for your better understanding, you just follow my pointer. So say there are three phases R, Y and B. Follow my pointer. This is R, this is Y and this is V. In each phase we have a wattmeter. See, with R phase there is a wattmeter 1, with Y phase there is a wattmeter 2 and this B phase we have a wattmeter 3. Now we know that in wattmeter, actually wattmeter is measuring what? It is measuring power. So what is the formula for power? V into I. If we consider the power factor is unity. So that means wattmeter is actually measuring the product of voltage and current, that is actually giving us the power of any single phase line. So can you think of that in wattmeter there are two coils? Not thinking, actually it is there in the wattmeter that in wattmeter we have two coils. Actually one is measuring the current, one is measuring the voltage. Okay, so as you can see, if we just view, follow my pointer, if we view this W1, in W1 we have a series coil and we have a parallel coil. Follow my point, this is a series coil and this is a parallel coil. So the series coil is measuring the current and the parallel coil is measuring the voltage of the system. The series coil is known as the current coil and this parallel coil is known as the voltage coil or pressure coil. So it is, in short, this CC, this current coil, and PC, pressure coil or voltage coil. So see, just carefully view in the follow my pointer. So in each phase, current coils in R, in Y, in B, in all phases, current coil is connected. Okay, and with each phase, the voltage coil is connected in between its own phase and in the neutral line. In case of R phase, it is connected between R and neutral. In case of Y phase, it is connected between Y and neutral, and in case of B phase, it is connected between B and neutral. Okay. So this is the connection for the star or delta connected system. If we use the 3 deltas, 3 wattmeter, and now coming to the delta circuit. See what is there. You can so this is wattmeter 1 in phase 1, this is wattmeter 2 in phase 2, and this is wattmeter 3 in phase 3. So now see, in them we have this current coil, this below one is the current coil is actually in series, and the pressure coil or the voltage coil is connected like this, where there is a inductance, there is a L2, L3, L1, so those things are there. So here is the same method. For potential coil is connected parallel, and current coil is connected in series. Here also it is series, and potential coil in the parallel. So okay, so this is the connection. But in case of delta, it doesn't have any neutral line, so you cannot say that there is a neutral line. So let us check what is written over here. The pressure coil of all the 3 wattmeter, namely W1 and W2 and W3, connected in a common terminal known as the neutral point, already discussed. The product of the phase current and the line voltage represent as voltage power and is recorded by individual wattmeter. Okay. That means what it is telling? It is telling that the product of phase current and line voltage is giving us the each wattmeter reading. I am already told you that that wattmeter is measuring voltage and current. So product of that is showing actually in the wattmeter. So let us come to the next slide. Yes. Now that was our connection diagram. Okay. So power will be the total power into what in the power will be. So in individual wattmeter is showing us some result, correct? So we will add all those things and we will get some total power. So as you can see, the total power P is given by here, that is W1 plus W2 by W3, where this W1, W2, W3 are V1 into I1, I2 into I2, I3 into I3. Okay, so here actually where we need three-phase 4-wire system, they are actually basically we use an unbalanced system, obviously. So we are actually we use the three wattmeter method. So but in experimental level, in maximum case, we actually use 2 wattmeter method. So next we are going to do the 2 wattmeter method. Yes. So the measurement of 3-phase power by 2 wattmeter method. Now first of all we will see what is the importance of 2 wattmeter method. Then we are going for the calculation part of all those things. Yes. So let us find out what is why we are using those the 2 wattmeter method instead of 3 wattmeter method. So 2 wattmeter method can be used to measure the power in a 3-phase 3-wire star or delta connected balanced or unbalanced load. It can be used for both balanced and unbalanced both. In 2 wattmeter method, the current coils of the wattmeter are connected with any two lines, say R and Y, and the potential coils of each wattmeter is joined across the same line, the third line, that is a B. So that means if there are 3 phase 1, 2, 3, so we are using 2 wattmeters. So 2 wattmeters is 2 coils. So say this is R, this is Y, this is B. So we are using with R phase there is a current coil, with B phase there is a current coil, and each wattmeter has a voltage coil. This W1 and W2 both have some potential coil. Those 2 potential coils are connected with this B phase. So R to B and Y to B. So potential current coils are connected inside the phase, and the potential connected coils are connected with R to B and Y to B. So like this, we will do later on that diagram, and better way we will going to understand that thing. Okay, the 2 wattmeter method is used for the power measurement in 3-phase system, irrespective of whether the load is balanced or unbalanced. So that's why that has a very important characteristics, and at the same time we can measure the 3-phase power using 2 wattmeter. So main thing is that one point is that, not main thing, that is the cost of the power measurement can be reduced. Correct? So instead of 3 we are using 2. So 1 wattmeter costing is reduced, can be reduced. So that's why it is one of the point. Okay. So coming to the next. So this 2 wattmeter method, by using 2 wattmeter method we can measure the power in star circuit, in the delta circuit also. So what thing we are going to do right now? So we will see in star connection what is the power value, in delta connection what is the power value. So just we have to see the diagram, and then we have to see the per phase voltage, line voltage, those things, and just there is a simple calculation from which we can find out what is the total power, and if we are measuring the power, is the correct one. Okay, so everything will be clear after this. Yes. So first here I am telling you that just carefully view the diagram and followed by pointer, so that you can better understand how the derivation is made in the next slide. So let us see what is there. So this is a 3-phase star connection. Obviously we can say that there is 3 phase R, Y, B, and in the previous slide is mentioned that 2 wattmeters are going to be used. This is wattmeter 1, this is wattmeter 2, and wattmeter we know that there is a current coil, there is a pressure coil. In second one also there is a current coil, there is a pressure coil. So current coils are connected in series with that phase, and the pressure coil is connected with the rest phase with which the any wattmeter is not connected. So second one is current coil is connected in series, and the pressure coil is connected with the B phase. So this is the connection system. Okay, so we are considering that through R phase IR current is flowing, through Y phase IY current is flowing, and through B phase IB current is flowing, and each phase there is a EMF voltage of ERN, the voltage in R phase and neutral. This is EYN between Y and neutral, and this is EDN between D and neutral. Okay, here. Okay, So as it is written that let W1 W be the 2 wattmeter, yes, we have considered. Let ERN and EBN the phase voltages across the three phase loads, correct? Okay. Let 3ERN, BN and YN all of the three phase voltages, and IR, IY, IB the phase current respectively. Yes, we have seen that already. Okay. Now the W1 the reading, so don't follow this our thing, just follow this thing, the last line, follow my point of this. There is a wattmeter, the wattmeter is showing us a product of this current and this EMF. What is the EMF? ERN minus EBN. Now again coming back to the picture, so what is written over here? So that is ERN minus EBN in case of W1, that is the potential difference. So how we can find out? So for W1, follow my pointer, so the current is flowing through this particular phase is IR, this is correct. Now what is the voltage? Voltage is actually, so this potential coil is connected between this R phase and B phase. So R phase has some voltage. What is the voltage? ERN. And what is the voltage of this the B phase? EBN. So what is the difference between this? Is in R phase we have the voltage of ERN, and in this B phase we have the voltage of EBN. So what is the difference between these two? That will actually appear in this parallel coil, correct? So the formula will be this current and difference between this phase voltage and this phase voltage, ERN minus EBN. Now let us check if it is there. Yes, IR into ERN minus EBN. So like this way, can we say that in case of W2, what is the voltage? So here the current we can say that is IY flowing through the Y phase. And what is the voltage? Voltage is the difference between Y phase and B phase. What is the voltage of B phase? Y phase, sorry. What is the voltage of this Y phase? Y phase is EYN. And what is the voltage of B phase? EBN. So what is the difference is appearing? EYN minus EBN. So here it is YN, follow my pointer, EYN, EBN. So difference between these two will give us this result. Okay. Now coming to, yes, see just IY, the current flowing through that particular phase, and the difference between two phase voltages, EYN minus EBN, correct? So this is the wattmeter reading actually we are going to get from this 2 wattmeter method. So there is a W1 reading and there is a W2 reading. If we add this 2 wattmeter reading, then definitely we will get the total power. So let us check we are getting or not. Yes. So W1 plus W2 we are adding. So follow my pointer. So we are adding this to, so W1 plus W2, that is W1 value is given over here and W2 value is given over here. Now just multiply. Okay. After multiplying, just what we have done, so all positive components taken the left side and all the and the negative components taken the right hand side. Okay. So now after that we know that in case of if we apply the KCL at a node, and if it is a balanced system, then we can say that IR plus IY plus IB is equal to 0. That is the total incoming and the outgoing current is value is equal to 0. So from that equation, can we say that IR plus IY is equal to minus of IB? Yes, we can say. So that means IB only we have taken the right hand side of the equation. So it will be minus IB. That means IR plus IY is equal to minus IB. So now put that in the equation. So if we instead of, so follow my pointer, instead of this IR plus IY, if we put minus of IB, so then this equation will appear. So minus minus will be plus and EBN into IB. Okay. So now what we can see, so this is the phase R phase volt power, this is the Y phase power, this is the B phase power. So by measuring this using this 2 wattmeter, we can say that, and we can see that three phases power are individually measured and it is additive over here. So we can conclude that using 2 wattmeter method, we can measure 3 phase power of a 3 phase system. Okay. So this is the importance of this study. Okay. Coming to the next. Yes. Now we have done right now that is the star connection. Now we are going to deal with the delta connection. Okay. Yes, let us see what is there. Similar notations are also mentioned over here. So in R phase we have a current IR, in Y phase we have a IY, and B phase we have a IB, and in star connection we have assumed the voltages, and in the delta connection obviously we are going to assume we are going to consider, not assume, we are going to consider the currents. So what are the currents we have? See, there is I1, this is Z1 branch, there is I2, there is Z2 branch, there is I3 into Z3 branch. Okay, so let us see what is the power consumed by this 2 watt meter. Let us see. Okay, see again, see this one, W1, that is the reading of the first watt meter. What is the reading? See, just check, ERB into I1 minus R3, I1 minus I3. See what it is told, what it is told. So what is told over here. So this is the voltage, this is the we have already know that what is the line voltage, the voltage between any two phase. So this is the line voltage actually, the VRB, which is the line voltage into the current flowing through this one. What is the current? That is IR. So if we convert this in terms of I1, I2 and I3, so what is the current? So IR is coming, means here it is the difference between these two current, I1 and I3, correct? So we can say that IR is equal to I1 minus I3. So coming to the next, yes, see the first line, the IR is equal to I1 minus I3, and the line voltage ERB, the voltage between R phase and B phase. So the instantaneous power measured by this wattmeter W1 will be this one, that is the line voltage ERB into the IR, and again IR is equal to I1 minus I3. So that equation actually depicted over there. Follow my pointer. This is the equation for the wattmeter. So coming to the next, yes. So again IY is equal to the difference between I1 minus I2. See again here, IY is equal to I1 minus I2. See, as the directions are opposite, so we have to do that. So this is I1 minus I2 is equal to IY, I2 minus I1 actually, that is IY, and this is the voltage is EYB. So EYB, let us check EYB. So the voltage between the line voltage actually, this is the EYB between Y and B phase. So EYB, this is EYB. So what is the power? So power is the voltage into current. So that line voltage into the current. What is the current? Current is the IR, and what is IR? So not this one. IY. So what is IY? IY is the I2 minus I1. So the power is given by W2 is equal to EYB into I2 minus I1. So like previously we have done, here also we can do that. Now we are going to see if we add the 2 wattmeter readings. So is it going to show us the total power of the system or not? If yes, this method is correct. If not, so there should be some change. So let us see what is the calculation is showing us. So W1 plus W2 we have noted down over here. So we have placed all the values. Okay. So here as we can see that just place the value, multiplied, then taken the positive component one side and negative component one side, then as we can see that this minus we have changed this one, that is minus ERB to plus ERB. Okay, that is actually the phase shift only. Okay, and so this is not ERB is equal to it should be BR, only changes of the name, RB to BR, this change, actually there is a typing mistake. So ER to BR, so that change we have done, that's why the elimination of minus. So now we know that from the concept of KVL, so all the summation of voltage is equal to 0. Okay, so now EYB plus EBR, EYB plus YBR is equal to what? Minus of ERY. Okay, so minus of ERY, so minus of ERY, So if we place the minus and minus, that is the plus. So here I1 into ERY. So see here, yes, it is coming I1 into ERY, and the next two components I2 into EIB and I3 into EBR. So it is showing the each phase power. So now we can say that it is showing us all the power in the three phase line. So we can say that using 2 wattmeter method we can measure the three phase power of any three phase system. Okay. So what is written? The power measured by the 2 wattmeter at any instant is the instantaneous power absorbed by the free load connected to the connected in three phases. Yes, in fact, this power is the average power drawn by the load, since the wattmeter reads the average power because of the inertia of the moving system. Yes, it is correct. Now we are going to see the last thing, that is a single phase wattmeter method. So inside that, what we have only we are going to see in a wattmeter there is a current coil, pressure coil. That thing repeatedly I have discussed in this presentation. So in any one phase we are going to connect a wattmeter, and it will going to measure the power, and we are considering that we are connected as a three phase balanced load. That's why in each phase the power consumption will be same we are considering, and that's why in one phase we are going to measure the power, and it will be multiplied with 3, and that will give us the total power. So as you can see over here, so the 3 into power per phase, so it will give us the total power. So this is the method we can use, and this is all for today. So from this particular presentation, now what we have studied, so we have studied the different methods by which we can measure the total power consumed. So within that we have seen that 3 phase power measurement, 3 wattmeter power method, 2 wattmeter power measurement method, and single wattmeter power measurement method. So single measurement wattmeter power measurement method is not up to mark as for the point of accuracy. 2 wattmeter method is more accurate from single phase wattmeter method, and it is mostly used. 3 wattmeter method is again mostly has high efficiency, but its cost is high, but instead of 2 wattmeter method. So approximately from accuracy and economics point of view, 2 wattmeter method is the best applicable method nowadays. So this is all for today. Thank you.